The apple is an ancient fruit steeped in mythology and history, but the modern apple orchard looks less like a traditional farm and more like a high-tech science experiment. Gone are the days of giant sprawling trees that required massive ladders to harvest. Today's commercial orchards utilize high-density planting systems. Apple trees are grafted onto dwarfing rootstocks, which genetically limit the tree's size to about 10 feet. They are planted just inches apart and trained along wire trellises, forming a fruiting wall that resembles a vineyard. This architecture is intentional. It allows maximum sunlight to penetrate every part of the tree, ensuring that every apple turns a uniform deep red, and it allows for the use of robotic platforms and mechanical aids during harvest. Despite this modernization, the harvest of premium table apples, the fruit destined for your lunchbox, remains an intensely manual task. A machine cannot yet replicate the complex decision-making and gentle touch of a human hand required to pick a dessert apple without bruising it. Harvest crews move through the rows with heavy canvas bags strapped to their chests. They use a specific technique: lift, twist, and pull. This ensures the stem stays on the apple. If the stem is pulled out, it creates an open wound where rot can enter, and the apple is downgraded. The pickers gently release the bottom of their bags to roll the fruit into large wooden or plastic bins, which can hold up to 900 pounds of apples. Once filled, these bins are loaded onto trucks and rushed to the packing house. Speed is essential because apples continue to respire after picking. They are burning up their own sugar and losing moisture every hour they sit in the heat. Upon arrival at the factory, the apples are introduced to one of the most fascinating transport systems in the food industry, the water flume. Apples are notoriously sensitive to impact damage. A bruise renders them worthless for the fresh market. To solve this, the factory uses physics. The entire 900-pound bin is submerged into a tank of water. Since apples are less dense than water, they float. As the bin sinks, the apples gently lift off and drift away, carried by a man-made current. This water highway is a network of flowing canals that winds through the factory floor. The water acts as a cushion, preventing the fruit from banging against metal sides or colliding with other apples. As they float along this serene river, the cleaning process begins. The water is often treated with mild sanitizers like chlorine or ozone to kill surface bacteria. The apples pass through bubbling sections, similar to a jacuzzi, which help loosen orchard dust, leaves, and any insects clinging to the skin. They then climb a conveyor belt out of the flume and enter the wash station. Here, rows of rotating soft brushes and biodegradable soap scrub the fruit vigorously. This is necessary to remove soil and chemical residues, but it has a significant side effect. It washes away the apple's natural wax. In nature, an apple produces a dull, whitish bloom of wax to seal in its moisture and protect it from the elements. Without this barrier, the apple will quickly shrivel and dry out. To fix this, the industry applies a cosmetic and functional upgrade. The apples pass through a waxing tunnel, where a fine mist of food-grade wax, usually carnauba wax derived from the leaves of a Brazilian palm tree, or shellac from the lac beetle, is sprayed onto the skin. Only a few drops are needed to coat thousands of apples. Polishing brushes made of horsehair spin rapidly, buffing this wax layer until the apples shine like a mirror. This shine is what consumers have come to expect, but its primary function is to act as a barrier for moisture loss, extending the apple's shelf life by weeks. Underneath the bright factory lights, the river of red and green apples looks like a flow of polished gemstones, ready for their final exam. After the washing and waxing, the apples race towards the sorting room. In the past, this job was done by hundreds of workers standing by conveyor belts, visually inspecting the fruit. Today, it is done by the Global Scan, an advanced artificial intelligence system. As the apples rotate on individual cups, they pass through a black box containing high-speed cameras. These cameras take up to 60 images of every single apple in a fraction of a second. But they don't just see visible light. They use near-infrared spectroscopy to see inside the fruit. The computer analyzes the light refraction to detect internal browning, water core rot near the seeds, and even the sugar content of the apple, without ever cutting it. It measures the diameter, the color percentage, and the weight to the milligram. Based on this data, the computer makes an instantaneous decision. It directs the apple to one of 60 different drop points. A puff of compressed air or a mechanical solenoid kicks the apple into its designated tray. The biggest, reddest, most perfect apples go to the premium export boxes, bound for Asia or the Middle East. The slightly smaller ones go to domestic supermarkets. The tiny ones go to school lunch bags. The technology ensures that every box contains identical fruit, consistent to the millimeter. But here is a secret that most consumers never suspect. The crisp, juicy apple you buy in the supermarket in August was likely harvested the previous October. It is nearly a year old. How is this possible without the fruit rotting or turning mealy? The answer lies in massive sealed vaults known as controlled atmosphere, CA, storage. This technology is essentially a time machine for fruit. An apple is a living organism. Even after it is picked, it breathes. It takes in oxygen and releases carbon dioxide and ethylene gas. This respiration burns up the apple's sugar and structural pectin, causing it to soften and rot. To stop this, scientists found a way to put the apple into suspended animation. The factory moves millions of bins of apples into airtight refrigerated rooms the size of gymnasiums. Once the door is sealed, nitrogen generators pump nitrogen into the room to flush out the oxygen. Normal air is 21% oxygen. Inside these vaults, the oxygen level is dropped to a suffocating 1 or 2%. The temperature is lowered to just above freezing, 32 to 34 degrees Fahrenheit. In this low oxygen, cold environment, the apple's metabolism slows down to a near halt.
When the flesh of an apple is
essentially
exposed to air,
stops
the enzyme
aging.
polyphenol oxidase
Sensors
causes a
constantly
reaction known as
monitor the gas
oxidation,
levels.
resulting in this
If the
brown
oxygen
color.
drops too low, the apples will suffocate and die, ferment. If it gets too high, they will wake up and age. It is a delicate balance maintained for months. When the market price is right, a room is opened, the oxygen rushes back in, and the apples wake up, as crisp and fresh as the day they were picked. But what happens to the apples that don't make the cut? The ones with hail damage, cuts, or weird shapes? They are not thrown away. They are the heroes of the juice industry. These cull apples are diverted on a separate conveyor belt to the processing wing of the plant. Here, aesthetics don't matter. The apples are washed and then dropped into a hammer mill. This machine spins metal hammers at high speed, pulverizing the whole apples, skin, seeds, core, and flesh, into a chunky mash called pomace. This mash is then treated with enzymes to break down the cell walls and release more liquid. The pomace is fed into massive hydraulic presses or continuous belt presses. The visual is intense. Tons of brown mash are squeezed between rollers, and a river of golden liquid pours out. This raw juice is cloudy and full of sediment. To make the clear juice found in bottles, it undergoes filtration through diatomaceous earth or ultra-fine ceramic membranes that trap even the smallest solid particles. The clear juice is then pasteurized, heated to 190 degrees Fahrenheit for a few seconds to kill any E. coli or salmonella bacteria before being bottled. Nothing is wasted. Even the dry cake of skins and seeds left over from the press is dried and sold as cattle feed or used to extract pectin. From the high-tech preservation vaults to the violent crush of the press, the apple factory is a zero-waste ecosystem where science squeezes value out of every single atom.
This is for you, Miss Davis.
Oh, thank you so much. That's very sweet.